It is scattered by the dust particles of the medium. So, sunlight, the word scatter means just split around. A very crude word I have used. Two types of scattering, coherent scattering and incoherent scattering. Coherence, if the wavelength of light is less, light of shorter wavelength. Hello students, let us now continue our discussion on the chapter Geometrical Optics and Optical Instruments. In today's session, we will study a very interesting as well as a beautiful phenomenon associated with light called as scattering of light, and also learn about one of the natural optical instruments, what we call as our eye. So thought focus now. My first part of the discussion will be with respect to scattering of light. So we start discussing the phenomenon of scattering. Fine. People who are affiliated to play the carom, you take the striker, hit the pawns. You see, the pawns are scattered, or what we say, the pawns are deviated in all possible directions, in all available directions. There is scattering or deviation of the pawns. The word scatter means just split around. A very crude word I have used, just to deviate in all directions. That is what we call as scattering. Then what actually do I mean when I refer to scattering of light? I will consider a test tube which is filled with some solution. So I have a test tube which is filled with some solution, and these are the particles of that solution, or I can say particles of that medium. My dear students, when light travels in vacuum, when light travels in free space, it is not scattered. It does not deviate from its lateral direction. But here, I consider a beam of incident light falling on this solution. A beam of light which will pass through the solution. Now what happens is the particles of this medium will deviate light in all lateral directions, where lateral means perpendicular directions. So the beam of light is scattered or deviated by the particles of the medium in all lateral directions, in all perpendicular directions. And this is what we call as scattering of light. Therefore, by definition, as light travels through a material medium, very important, I told, in free space, in vacuum, there is no scattering of light, there is no deviation of light. The phenomenon of scattering happens in a material medium. So, as light travels in a material medium, the particles of the medium will deviate light in all lateral directions, in all perpendicular directions. And this phenomenon is called scattering. The phenomenon of scattering is also called irregular reflection of light. It is called irregular reflection of light because sometimes partly the laws of reflection holds good here. So, what is scattering, my dear students? It is the phenomenon of deviation of light. Who is deviating light? The particles of the material medium in all lateral directions, perpendicular directions, and that is what we call scattering of light. Now, there are two types of scattering. One is called coherent scattering. The other one is called incoherent scattering. There are two common words which we use in physics. One is called resonance and the other one is called coherence. Two commonly used words, resonance and coherence. Here resonance means frequency matching condition. Resonating length and totira, frequency of the applied force becomes equal to natural frequency. Resonance is set up. The word resonance means frequency matching condition, and the word coherence means wavelength matching condition. Resonance refers frequency matching condition. Coherence refers wavelength matching condition. If so, then what is coherent scattering? Wavelength match agbekello. Here, the wavelength of the scattered light is the same as the wavelength of the incident light. So if lambda of the scattered light is same as the lambda of the incident light, so wavelength of this incident light matches with the wavelength of the scattered light, then such type of scattering is called coherent scattering. The wavelength of the scattered light should be the same as the wavelength of the scattered light. Coherence means wavelength matching condition. Example, Tyndall scattering and Rayleighs scattering are examples for coherent scattering. An important 1-mark question. When it comes to incoherence andre the other way, wavelength will not match. Here, the wavelength of the scattered light is different from the wavelength of the incident light. So, during incoherent scattering, the wavelength of the incident light and the wavelength of the scattered light will not match. They are different. Therefore, there is no coherence. And Raman scattering is the best example for incoherent scattering. So, scattering, light passes through a material medium. The particles of the medium deviate light in all lateral directions. That is scattering, which is also called irregular reflection. Two types of scattering, coherent scattering and incoherent scattering. Coherence refers to wavelength matching condition. So wavelength of scattered light is same as wavelength of incident light. During incoherent scattering, wavelength of scattered light is different or does not match with the wavelength of the incident light. Now, a very, very important law, Rayleighs Law, which will actually explain beautiful phenomena like why sky is blue in color, why it is red or orange during sunrise or sunset. A very established law for scattering. Rayleighs Law says the intensity of scattered light. Which light? Scattered light. Intensity of the scattered light is inversely proportional. Direct alla, inverse. The intensity of the scattered light is inversely proportional to the 4th power of the wavelength of incident light. 4th power of wavelength of incident light. So we say the intensity of this scattered light is inversely proportional to the fourth power of the wavelength of incident light. So we say I proportional to 1 by lambda to the power 4, very much established as Rayleighs Law of scattering. So what does Rayleighs Law say? Intensity of the scattered light is inversely proportional to fourth power of the wavelength of incident light. Which means to say, light which has shorter wavelength, light which has less wavelength is scattered more, inversely related, and vice versa. As the wavelength of light increases, scattering decreases. Now, the question that we have to answer now is, why does sky appear blue? What is the basic cause for the blue color of the sky? And the answer is from Rayleighs Law. What does Rayleighs Law say? Intensity of scattered light should be inversely proportional to wavelength of incident light. If the wavelength of light is less, light of shorter wavelength will be scattered more. Now, as sunlight passes through the atmosphere, it is scattered by the dust particles of the medium. So, sunlight is passing through the atmosphere. The dust particles of the medium will scatter sunlight, which means violet, indigo, and blue have less wavelength, shorter wavelength, and they are scattered most. Which are they? Violet, indigo, and blue. They are less in wavelength, shorter in wavelength. So scattering is more. But why do we feel or see that sky is blue? Because our eyes is sensitive to blue color. That is why sky appears blue. See, very beautiful. As the wavelength of light is less, its scattering is more. Sunlight is passing through the atmosphere. It is scattered by the dust particles of the atmosphere. So naturally, light with shorter wavelength has to be scattered more. Which are those three colors? Violet, indigo, and blue. But since our eyes is sensitive to blue color, scattering or the sky appears blue. Similarly, why sky appears red at sunrise and sunset? During sunrise or sunset, at the horizon, we receive least scattered colors. During sunrise or during sunset, at the horizon, we always receive least scattered colors. Least scattered colors will have maximum wavelength. And which are the colors with maximum wavelength? Red or orange. Therefore, the sky appears red at sunrise and sunset. Then why does the ocean or sea appear blue? It is reflection of light from the sky. That is why the blue color of the sea comes into picture. Now, we will understand one of the natural optical instrument, beautiful, what we call as eyes, the most sensitive part of the human body. Without eyes, we could not have the sensation of vision caused by light. Eyes, we could not feel ourselves. A very, very important natural optical instrument. In your bio, you have studied very much with respect to eyes. Now, we study something called blind and yellow spots related to eyes. Blind and yellow spots, something concerned to eyes. We say least sensitive spot to light is the blind spot and most sensitive spot is the yellow spot. Blind spot andre, it is very much insensitive to light, or what we call least sensitive point on the eye to light. And the most sensitive point is the yellow spot. This is called accommodation power. Again, a very important definition. Accommodation power. Ability of the eyes to see far away objects, clear and distinct, is called accommodation power. Far point, the most distant point which the eye can observe clearly, the most far away point is called far point, and for normal eye it is infinity. So students, in today's class, we have understood a beautiful phenomenon of scattering, Rayleighs Law, which explains the blueness of the sky, why it is red during sunrise, and also the blueness of the sea. And finally, a few terms with respect to eye. Next, we understand the working of a few optical instruments. Until then, thank you.